Hello, everybody. Today I'm going to talk about transformations of quadratic functions in vertex form. Yesterday, you went through this Desmos activity, and one of the things that it discussed was the parent function, which is this equation here and this graph here. So if we go to our page of notes, we can start filling this information in as we go through it. So the parent function is what we call the simplest quadratic equation, and it is y equals x squared. Okay. And again, this is known as the parent function. Now, a few days ago, we talked about what was vertex form, which was y equals a times x minus h squared plus k. So what we're going to be looking at and what you looked at in your Desmos is what, as you change h, k, and a, what does that do to this parent function graph that we see here? This is what we call a transformation. The transformation can change the size. It can also change the position of a figure, our figure being a parabola. Okay, so let's go to the back of our page and let's talk about what you came up with yesterday in your Desmos activity. So if we go to the Desmos activity, let's talk about what happens when h changes. So if we go to the Desmos activity here, one of the things you were looking at is as we change the h value, what happens to our graph? So what happens to our graph when I change the h value to something bigger, like 1 or maybe even 2, right? So if I change the h value to a positive 2, what happens to our graph is it moves to the right. Not only does it move to the right, but it moves to the right 2 places. Then if I take my h, if I put it back to 0, that would be the parent function h value of 0. As I change it and I make it go to the left, right, doesn't really matter what we make it, but we can see here I've moved it to the left. With an h value of -4, it would move to the left 4 units. Now remember, when h is negative, it will appear as a plus sign in the equation because of how a negative and a negative work when they are put together. So what's going to happen with our h value is the h value is going to give us what we call a horizontal shift, meaning it's going to move to the right or it's going to move to the left. Okay, so if your h value is positive, okay, if you see that the h value is positive, meaning h is greater than 0, that's going to move your graph to the right. And if our h value is negative, meaning h is less than 0, it's going to shift it to the left. Not only will it shift it left and right, but it'll shift it that number of units. So if h is 2, it'll go to the right 2. If h is -1, it will go to the left 1. Going back to our Desmos activity here, I'm going to go ahead and put that back at 0. Okay, and let's look at what happens when I move the k value. If I change the k value, I could just type something in like 5, and you can see what happened to our graph. It went from 0 and it went up to 5. I could, change it to a 3, and you can see here that it's gone up 3. If I change k to something negative, like -2, you can see that the graph is moving down, and it's moving down too. So going back to our notes, we can say that if you change k, k is going to give you what you call a vertical shift. Again, if the k value is positive, meaning bigger than 0, versus the k value being negative, so that's less than 0, positive k value will shift it up, and the negative will shift it down. Okay. The next thing that was discussed was the a value. So if we go to how the a value changes the graph, let me get to that slide. So here's this slide here. Let me go back to an a value of not 11, of 1. In the parent function, the a value is a 1. So what happens with the a value, first of all, if I change the a value just from 1 to a -1, you can see what happens is our graph faces down. And we've talked about that before, that a positive a value will make your graph face up and a negative a value will make your graph face down. So if we look at our a value is negative, what that's going to do to your graph is it's going to cause what we call a reflection. Okay, it's going to reflect over, you can say the word over or across the x-axis. Okay, and with this function that is reflecting, you can, some people like to say flip instead of reflects. They might say the word flips. That's fine too. Whatever, you're just describing it. So however you describe it, as long as it makes sense, is fine. So let's see what else a does. So with a, if I change a, so let me change it back to positive. Okay, so if I change a to something like a bigger number, so like 3. So if I change it to a 3, and I'm actually going to add a line here and put the parent function in there so you can compare it. So the red lines are parent function. Okay, there it is. And then this is the purple one's the one that's changing. So again, from the red line to the purple line, as I changed a to something bigger, okay, my graph got more narrow. Okay, they call that a vertical stretch because you're stretching it in the vertical direction. Okay. So again, if we go back to our notes, if the a value is greater than 1, okay, that's going to represent what we call a vertical stretch. Feel free to describe that as becoming more narrow. I think the Desmos said something about it being more skinny or skinnier or something like that. That was on another slide. So let me take that a value and put it back to 1. So there it is. Okay. That's our parent function again. If I change the a value to something like 1/2, so some sort of decimal value that's smaller than 1, but still bigger than 0, right? Then that's going to create something that's more wide. If I want it to be even wider, I can just make it a smaller fraction, like 1/8. The smaller the fraction, the wider your parabola is going to be. Now, I can combine the reflection with it being more wide by just making the a negative, right? So the negative flips it. The fraction value of a 1/8, or that decimal value, if you're looking at that, is what makes it more wide. Okay. So if we're looking at a value between 0 and 1, like you saw I did 0.5, I did 0.125, okay, this would be called a vertical shrink or compression is the words that you will see. In these notes, they use the word compression. And they use the word compression because it's compressing down towards the x-axis, becoming more and more flat. Okay. And I think the Desmos activity said something about it becoming more wide. Again, you can describe it using whichever words you want to use as long as it makes sense to what is happening in the problem. Okay. And then in the Desmos activity, they actually do a really good job of describing that here on slide 23. So if you need a little bit more information or see different words, you can go ahead and look at that. Okay, so let's go ahead and do a couple of examples here. Okay, and some of these problems that we could graph them, and you can see that on all of these pictures, that graph that they have there, that is the parent function. So don't think that it's already graphed. That's the parent function. So what you are going to do is you are going to graph these vertex form problems by stating the vertex in this first space, giving me some more points. You don't need to use all of these. That's why the last are scribbled out, and you'll graph this function. The other thing they want you to do is to describe the transformation, okay? So when we're describing the transformation, like I'll go to number 9, okay? So on number 9, you'll state your vertex, you'll find some more points, and you'll graph your parabola on this xy axis. And again, this is the parent function. If I wanted to describe the transformation from the parent function y equals x squared, I would note here that I have an a value of 1. Okay, my a value is 1, and when your a value is 1, that doesn't change anything from the parent function because in the parent function, they've a value is 1. Okay, so that means I don't need to describe anything about reflection. I don't need to describe anything about skinny or wide. But I do see here that I have an h value. Okay, so my h value here, oops, right here, is -1. Because remember, our vertex is hk, so we're going to have an h value of -1, and our k value is -6. So we'll have a k value of -6. Okay, so I am going to have a shift left or right, and I am going to have a shift up or down because the h and the k value are changing. So when I go to describe this, okay, over here in this box where it says transformation, you're going to describe this. Since h is -1, I'm going to go ahead and say that my graph shifts left 1. Okay, so from the parent function, my graph's going to shift left 1. But because of the k value, it's also going to be shifting down. So it's going to shift left 1 and down 6. So describing what's happening from this graph to this graph here, shifting left 1, down 6. So I know that my vertex is going to be down here, and the width of my parabola is going to be exactly like the parent function. And it's not reflected because a is positive. Okay, so if we look at one like, I don't know which one we can do next. Like, let's look at number 11 here. Let me do one that's negative. I don't know if there was any examples of those. I'm gonna might have to add some in here because there weren't many examples of what I wanted. So let's imagine that we have y equals negative x minus 4. And I guess you guys can add this in over here in this column. There's space here. Okay, so like y equals negative x minus 4 squared. Let's just do an example like that. Okay, so on this problem here, okay, if I wanted to describe the transformation, I would see that my a value here is negative, and I would notice here that my h value is a positive 4. Okay, so that means that because of the a value, my graph is going to reflect over the x-axis. You can also say it flips over the x-axis. That's fine to say. And then, because the h value being positive 4, you would also state that it's going to shift the direction being to the right because it's positive 4. And how far? Well, it's going to shift right 4. So there's an example with that negative in there. So how would we describe something that has like an a value that's like, like number 11 or number 12 here? Okay, so on number 11, I'll do the transformation for number 11. On number 11, I can see here that my a value is positive 3 and my k value is negative 7. Now, when you go to find the vertex of this problem, you will notice that our h value, right? Remember, because if it's x minus 0 squared, they're not going to write this x minus 0 because x minus 0 is just x, and x squared gives you x squared, okay? All right, so that means that our h value is actually 0, and our k value, as we know, is negative 7. Because our h value is 0, there's no shift left or right. Okay, and because our a value is positive, there's no reflection. So if the transformation is not happening, you don't need to name it. So what I will then describe is what happens because of my a value being 3. Since my a value is a value bigger than 1 as opposed to a value between 0 and 1, I'm going to say that I have a vertical stretch, okay? And it's the vertical stretch by a factor of 3, okay? Because reason why I'm using factoring, the word factor, is because 3 is being multiplied to the x squared. So it's a vertical stretch by factor 3. You could also say the graph is more wide by factor 3. That would also work. So because of the k value, I do have a shift. My graph is going to shift down 7. Okay, so my graph will shift down 7, and that will create the new graph and tell you the transformation of it. Okay, so you could continue with this problem and fill in more points. Obviously, these are scribbled out for you, and then you'll graph some more there. The last thing is down here, writing an equation. When you're writing an equation, basically what you're going to do is you are going to take your vertex form and you're going to read the description here, filling in values for a, h, and k, depending on the transformation that is being described. So, for example, like on number 19, if I did number 19, I can see I have a vertical compression by a factor of 1/3. That means that I have an a value of 1/3. And it also says I'm translated 8 units up, which means I'm going to have a k value of 8. And remember that in the parent function, if you recall in the parent function, the a value is 1, the h value is 0, and the k value is 0. That's why the parent function reduces to y equals x squared. So if you don't have a reflection, don't make the a negative. If you don't have a shift left or right, don't add in a h value. Okay, so when I go to write my equation, I'll have y equals my a value of 1/3. I don't need a parenthesis, sorry about that, because my h value will still stay 0. So I can just write it as x squared. Okay. And then going up 8, that would be a plus k value, so plus 8. So it looks something like that. Okay. Let me do one more. I'll do 18. So on number 18, I have a reflection over the x-axis that tells me that your a value is negative. Then I have a translation 5 units to the right, which tells me that h is 5. And then I have 2 units down, which tells me that k is 2. So if you went and plugged that into your vertex form, that would be y equals, your a value would be negative, so technically it's -1. You can write the -1, I'm just going to write negative. Then because I have an h value that's not 0, so this wouldn't simplify to x squared, I have to put the parentheses. So it'd be x minus, the h value is 5, close the parentheses, square it. And then my k value is plus 2. So then that would be your answer. So what you are going to do now is you will work on the rest of these problems and practice some more graphing on these problems for some more practice. Again, they're all vertex form. The only addition to the graphing is describing the transformation. And then you'll also complete this writing equations part as well. So I will have an answer key available to you tomorrow so that you can check answers and you can also ask questions.